Imagine, if you will, being able to eat breakfast yesterday. A fascinating thought, isn't it? This is the allure of time travel, a concept that has captivated the human imagination for centuries, even millennia. From the ancient sands of India, where the epic of Mahabharata spun tales of King Raivata Kakudmi, who journeyed to the heavens only to return to Earth centuries in the future, to the shores of Japan, where the fisherman Urashima Taro visited a mystical undersea kingdom and returned home to find himself 300 years in the future, the idea of moving through time has been deeply woven into our cultural fabric. These stories, while fantastical, reflect an age-old fascination with time and our place within it. They speak to our innate curiosity, our desire to explore the unknown, and our enduring quest to understand the nature of existence itself. In the Western world, too, we find references to time travel in the mythologies and folk tales of old. Take, for instance, the Irish legend of Oisin, who travelled to the land of eternal youth, Tir na Nog, only to return to find 300 years had passed in his homeland. Then we have the Jewish story of Honi the Circle Drawer, who slept for 70 years, an echo of the Sleeping Beauty tale that would come much later. These narratives, while differing in detail and context, all point towards a universal fascination with the concept of time travel. But time travel isn't just confined to the realm of myth and legend. With the advent of science and technology, what was once pure fantasy began to take on a new dimension. The question shifted from, can we travel through time, to how can we travel through time? From ancient myths to scientific theories, time travel has consistently fascinated us. But when did we begin to seriously consider its possibilities? Enter the world of science, where time travel is not just a myth, but a subject of serious debate. As we delve into the realm of scientific theories, it becomes clear that our understanding of time travel has been shaped largely by one man, Albert Einstein. His groundbreaking work in the early 20th century has set the stage for all subsequent investigations into the possibility of time travel. Einstein's theory of relativity, which he first proposed in 1905, revolutionized our understanding of time. It shattered the long-held belief that time was a fixed, unchanging entity, separate from space. Instead, Einstein proposed that time and space were interwoven into a single entity, space-time. His theory suggested that time could be bent, stretched, and even manipulated. This was a radical concept, one that opened up a world of possibilities, including the potential for time travel. But how exactly does this work? Imagine space-time as a fabric. According to Einstein's theory, massive objects like planets and stars cause this fabric to curve, creating what we perceive as gravity. Now, if space-time can be curved, it could theoretically also be twisted and folded back on itself. This could create a wormhole, a sort of shortcut through space-time that could potentially allow for time travel. But of course, this is all purely theoretical. While Einstein's theories have proven to be remarkably accurate in predicting phenomena like the bending of light around massive objects, the existence of wormholes remains unproven. Nevertheless, these theories have provided the scientific foundation upon which all subsequent investigations into time travel have been built. Indeed, Einstein's work has sparked a century of scientific exploration, debate, and even controversy. It has inspired countless researchers to delve deeper into the mysteries of time and space, to question the nature of reality, and to dream of a future where time travel might be possible. Einstein gave us the scientific foundation for time travel, but how far have we come since then? The 20th century brought us closer to the possibility of time travel than ever before. As our understanding of the universe deepened, so did our fascination with manipulating time. Theoretical physicists like the esteemed Stephen Hawking and Kip Thorne have made considerable contributions to our understanding of time travel. Hawking, known for his work on black holes and the Big Bang, proposed the chronology protection conjecture. This theory suggests that the laws of physics conspire to prevent time travel on all but microscopic scales. Hawking's work has had a profound impact on our understanding of the universe and the notion of time travel. On the other hand, Kip Thorne, a key player in the discovery of gravitational waves, proposed the concept of wormholes. These are hypothetical shortcuts through space-time that could, theoretically, allow time travel. Thorne's work has not only advanced our understanding of gravitational physics, but it's also given us a potential mechanism for time travel. In the realm of experimentation, researchers around the globe have undertaken thought-provoking studies. Take the Huffle-Keating experiment, which confirmed that time dilation occurs at high speeds, as predicted by Einstein's theory of relativity. Then there's the delayed choice quantum eraser experiment, which suggests that actions in the present can influence events in the past on a quantum level. These experiments don't definitively prove time travel, but they certainly add to its plausibility. It's important to note that while these theories and experiments are exciting, they're also controversial. The scientific community remains divided on the feasibility of time travel. Some argue that it's purely the stuff of science fiction, while others maintain that it's a distinct possibility, just beyond our current technological reach. Either way, these modern theories and experiments have played a pivotal role in furthering our understanding of time and its potential manipulation. They've sparked countless debates, inspired countless works of fiction, and captured the imaginations of countless individuals worldwide. While we've made significant strides in understanding time travel, it remains a complex and intriguing mystery. Time travel is not without its paradoxes and dilemmas. Let's dive into the fascinating world of time travel paradoxes, those mind-bending conundrums that pose significant challenges to the very concept of traveling through time. Two of the most famous of these are the grandfather paradox and the bootstrap paradox. To begin, let's explore the grandfather paradox. Picture this. You've built a time machine and you step back in time to an era when your grandfather was a young man, long before your parents were born. In this timeline, for some reason, you end up causing your grandfather's premature demise. If that's the case, one might ask, how could your parents have been born? And subsequently, how could you have come into existence to build a time machine and travel back in time? This paradox poses a significant challenge to the concept of time travel, suggesting that any action that would cause a change in the past, leading to an impossibility in the future, is inherently flawed. The grandfather paradox is an illustration of the potential inconsistencies that could arise from the ability to influence past events. Next, we have the bootstrap paradox, a concept that plays with the idea of cause and effect. Imagine you receive a book filled with scientific theories from a mysterious stranger who claims to be from the future. Inspired by this book, you dedicate your life to science and eventually write the very book that you received years ago. Now here's the conundrum. Who wrote the book to begin with? This is the bootstrap paradox, a circular occurrence where the cause and effect loop onto each other, making it impossible to discern the origin of the event. These paradoxes highlight the complexities and challenges associated with time travel. They force us to question our understanding of causality, existence, and the nature of time itself. The paradoxes of time travel continue to baffle us. But what does the future hold? The future of time travel is as uncertain as it is exciting. As we move forward into the uncharted territories of the future, the questions that have haunted our minds for centuries continue to persist. Will we ever be able to travel back and forth in time? Will we ever unlock the mysteries that time holds? The potential for future developments in time travel largely hinges on advancements in technology and theoretical physics. Imagine a world where quantum computers, powered by the strange rules of quantum mechanics, could simulate the entire universe. Such supercomputers could potentially allow us to understand the intricacies of time and space on an unprecedented scale. Theoretical physics, too, holds promising prospects for time travel. For instance, the concept of wormholes, bridges through space-time predicted by Einstein's theory of general relativity, could potentially be used for time travel, if they exist, and if we can harness and stabilize them. String theory, another exciting field, suggests the existence of multiple dimensions beyond the four we're familiar with. If we manage to prove this theory, it could open up new pathways for time travel. We could, theoretically, move between these dimensions, experiencing different timelines and realities. Moreover, the development of exotic matter with negative energy density could provide the key to creating wormholes that don't collapse, making time travel more feasible. Of course, these are all speculative ideas. We are still far from turning them into reality. The challenges are immense and the ethical and philosophical implications profound. Time travel could disrupt the fabric of our reality, creating paradoxes and altering the course of history. But despite these challenges, our quest for understanding time continues unabated. The concept of time travel fuels our curiosity, pushing the boundaries of human knowledge and imagination. Whether or not time travel will ever be possible, its mystery continues to captivate us. The allure of time travel, it seems, is truly timeless.